Okay, so here's problem 8. Again, I have more than one type of x, so I'm going to try to factor it. So I'm going to bring the 6x over by subtracting it. Equals 0 now. I'm going to make my x. Are there factors of 7x squared that get me to negative 6x? No, they're not. When I put these down, I need for these both to be positive to get to 7x, which then makes 8x, or I need these both to be negative to get to 7x squared, and then that would be a negative 8x. So this is actually not factorable. So I'm going to do the quadratic formula. A is 1, here's B, here's C, and I'm going to do x equals opposite B, plus or minus square root B squared, so that's 36, minus 4 times A times C, and it's all over 2 times A, which is 2. 2 times 1. So again, go to your calculator, and we're going to do 36 minus 4 times 1 times 7. And I get 8. So here's the first good answer Mrs. Slauson will take. You can run your factor program and see that 8 can be broken to this. So the first extra credit is, that's a 2. Great, you just got some extra credit. After that, maybe you'll notice that you can do that simplifying triangle and take a 2 out. So if I take a 2 out of here, I'm left with 3. Plus or minus, take a 2 out of here, you're left with the 1. You don't need to write the 1. And then this is a 1, which I don't need. So this is the best answer. There are no imaginary numbers, so Mrs. Slauson wants to know the decimals, so 3 plus the square root of 2. And again, I'm going to round to the nearest hundredths, and then you would do the same. You would do 3 minus the square root of 2. So, okay, so I do want to see both. All right, done with a little bit of solving. Now we're going to the next problem, which is change it from standard form to vertex form. That means we're going to complete the square. So the first thing, I can't complete the square until it's x squared. So as I group my x's, I'm going to pull a 2 out, take a 2 out of here, and then here's the blank for completing the square. Whoops. It should be minus. Okay. So again, take the 2 out of here and here. So I'm going to take my negative 8. I'm going to cut in half for negative 4. I need that number later. I'm going to square it, and I get 16, which is the number that goes here. But even though I wrote 16, hopefully we remember that 2 affects everything in here. So it's actually worth 32. So now you can start the process. When I combine those together, I get 32. I'll have a set of parentheses squared with this 2 that I took out coming down here, and then it's x plus this cut in half number. It does want you to afterwards state the vertex. So that's h and k. H and k are added. A is multiplied. H is in the house. You take the opposite of h, and you take the k as is. So here's my vertex. All right, number 10, substitution or elimination method for the system. So again, what you can do is when you're done, or you can do it now, you could go to the y equals button. You can put in those equations, maybe just to see what your answer is going to be first. Oops, minus 4. So I start out with zoom 6. And these are going to meet twice. So if you really want to know the answers ahead of time, you can go to second trace. We're going to choose intersect. And I'm just going to move the cursor. My cursor is already right by 1, so I'm just going to enter 3 times. And I get 0, 5. So I know one answer when I'm done is 0, 5. So I'm going to go ahead and put them down here. And the other one, so hit second trace again. Move it over to the other one. It's close enough. Hit enter 3 times. And I'm going to get negative 4, negative 3. Now what you have to do is prove those answers. This will not work. It says use substitution or elimination. Before I can do that, though, I've got to deal with these parentheses. So I'm going to deal with that first. That squared means I have this. So I'm going to do a little bit of foiling or distributing. So I get x squared plus 3x. Then 3 visits, I get another 3x and 9. There's still the minus 4. And now I can combine like terms. Those can make 6x, and these can make 5. So I have this problem, and I have the new version. And so, again, you can use any method you want. I think I'm going to use substitution. So since all of this equals y, I'm going to take the fact that this is y and just put it into here instead of lining it up. So y goes out, and 2x plus 5 goes in its place. Now I'm ready to solve. I have more than one type of x, so I'm going to get all the x's on one side in standard form so I can look to factor. I'm going to subtract the 2x to the 6x and get 4x. And I'm going to subtract the 5 over to the 5, and that's just 0. So when I'm done, it equals 0. And now this hasn't happened on a lot of problems, but what I have here is the only way I'm going to factor here is a greatest common factor. And so I'm going to take an x out, and I'm left with x plus 4. And now what makes each of these equal 0? Again, this is a simpler one. It's negative 4. And this one is so easy, it's tough. And so if you don't see it, you know, I can take it, set it equal to 0, and there's my answer. 0 makes it 0. So I've just have proved the x's. But remember, you still have to figure out the y's. So you need to take these x's and put it back into this one, or this one, or this one. I would prefer this one because it's the easiest. So for instance, I'm going to take the fact that x equals negative 4 and put it into here. So I'll just be taking 2 times negative 4, which is negative 8. And then I'm going to add 5 to that, and that's where I get the negative 3. So now I've just verified the negative 3 answer. And then I'm going to do the same, but this time I'm going to make x become 0 and put it into there. So 2 times 0 is 0. 0 plus 5 is 5. So now I've proven the other one. Again, you have to have work to back this up. So even if your calculator does this, write out, you know, at least this, so I know that you know where you got the y from. All right, now we moved into a little bit of simplifying with the imaginary numbers. The key part here is, you know, pay attention. Are you adding, subtracting, or multiplying? But this is the part where you have to remember that I squared is worth negative 1. So here I'm combining the two parentheses through subtraction. So I'm going to go through left to right and add the opposite. So I'm going to add, and I change one thing about 5i, it's negative 5i. And then this minus applies to the whole parentheses. So when I add, I'm going to change one thing about this one, it becomes positive. And one thing about this one, it becomes negative. And now I can combine my like terms. So you can check your work on the calculator, but I want to see some type of work like this. So 3 plus 8 is 11, and then negative 5i, and another negative 5i is negative 10i. Okay? The next one, these are connected through multiplication. So I just have to remember I'm distributing. So 2i visits 4i, that's 8i squared. 2i, I'm going to add the opposite here, visits negative 7, that's negative 14i. The 3 and the 4i become 12i, and the 3 and the negative 7 become negative 21. So what I'm going to do now is combine my like terms. This becomes 2i. This is where I squared is worth negative 1, so I'm really taking 8 times negative 1. So I really get negative 8 out of that term. And then I can combine these and get negative 29 plus 2i as my final answer. Moving down, 14 is just another multiplying. If you want, you can add the opposite. 6i distributes, I get 30i. 6i distributes, I get negative 12i squared, which again just means I'm taking negative 12 times negative 1, which is 12. So I replace it with 30i plus 12. And you can't combine those. Those are not like terms. One's real, one's imaginary. Last one, 13. Please pay attention. You're multiplying, or adding, not multiplying. I am going to add the opposite. So I'm going to combine my like terms. 7 and negative 6 is 1. When I combine my imaginaries, negative 9 and 5 is negative 4i. All right, moving on. Sorry, let's turn my page. A little bit more simplifying. Square root of a negative number. So first realize I'm going to have an imaginary. But I don't want the decimal. I want you to run your factor program and see that you can break this into 25 and 3. And then you have 2i now, and that's 5. And that stays there. And now I can put those two together for 10i radical 3. All right, number 6, another solving one. I have more than one type of x. I'm going to try to factor. So we get 10x squared for negative 2x. When I run my factor program, nothing's going to work. This is actually not factorable. So again, I'm going to do the quadratic formula. A is 1, b is negative 2, c is 10. So I'm going to take opposite b plus or minus this big square root of b squared, so that's 4, minus 4 times a and c. And it's all over 2 times a, so 2 times 1. So again, I can go to my calculator and type this in. 4 minus 4 times 1 times 10, that's negative 36. I guess I didn't need that whole square root. I could do this. And then it's all over 2. Not only is this imaginary, but it's also perfect. It's plus or minus 6i. So this is the first acceptable answer. Maybe you see the triangle, and I can take a 2 out. Whoops, sorry. So when I take a 2 out of here, I'm left with 1. Take a 2 out of here, I'm left with 3i. Take a 2 out of here, it's just left with 1. So I don't need the 1 in the denominator, just up and top. So not quite. First acceptable answer, extra credit. All right, 17. Your job is to use the graph to determine the number of solutions and then the type of solutions. Are they real or imaginary? And if it does have the solution, name them as a point, which means I want an x and a y value. So first, this has one solution. It's coming into contact with the x-axis. It's a real solution. And what is its value? It is negative 3, 0. This one, here's the x-axis, here's the y-axis. This actually never makes contact with the x-axis, so these are imaginary, which means you won't give any. And the last one, these are real. There's 2 of them. This one is negative 1, 0. And the other one looks like it's 1.5, 0. Okay? All right, 18, another substitution.